So now we're at the last example that we're going to go over in section 7.3. We're on page 377 and I'm down at the bottom of the page at example 7-7. The example is home fire started by candles. And every time you're doing an example, and you'll notice in the notes I even say, right now try to do it on your own without the notes. Because when you get to the test, you've got to figure out which question it applies to, which formula it applies to, pick out pieces, pick out parts, what all is going on. Well, here's the last one in this section. We have data, random sample, number of homes started, fires in homes, home fires started by candles, past several years, and it's taken from NFPA. Find the, and then we start to get some information. 99% confidence interval, so it's either going to be a Z or a T, for the mean number of home fires started by candles, and that's all they gave us. So I'm making a whole video just on this one problem because we're going to have to look at the raw data from a sample. And since it is from a sample, that would tell us that we're going to be using T because I'm not given my population mean. I'm going to have to calculate my sample mean. I need to find out what that, that's the sample standard deviation. I need to find out what my sample mean is. I'll have to go get my T off the chart. I got to figure out what the size of my sample is, and then I've got to go calculate the standard deviation for my sample. Then I'll plug all this in, and it will be back to business as usual. I want to work through all of this one because it's been a while since we did some of this information, and the final will be here very soon. So here we go. When we're looking at this formula, and I'll try to cover up parts of it. When we're looking at the formula, gonna need a bigger one. We need bunches of pieces and parts. We're gonna need the average. We'll need the average. That should be pretty simple, right? If I have data, I should be able to add them up and divide by how many ever pieces of data are there. Oh, I need the N anyway. 1, 2, 3, 4, 5, 6, 7. Here's a piece of information. Our sample size is 7. When we go to get degrees of freedom, it'll be 7 minus 1. We'll be using 6. Well, I guess I'll go ahead and write that down again. And we'll need 6 for that. The formula starts out needing the mean of our sample. So let's practice that. Make sure you're practicing. Make sure you can do this on your own. Make sure that you've got ways to be smarter than your calculator. I'm trying to find a place this won't glow or reflect, but that's not going to happen right now. So I'm just going to start punching stuff in. I'm going to start punching in all of my pieces of data. I'm going to punch in the 5460 plus, 5900 plus, and I should be checking. See, I've already typed something in wrong. 5460 plus, 5900 plus, 6090 plus, and I should be double checking it, and I'm not. 6310 plus, 7160 plus, 8440 plus, 9930. So what you're doing right now is our class time, and it should be just like we are in class. And so I get a number of 49,290, and then I'm going to divide that by my the number in my sample. I want to go ahead and write that down, that my X bar is 49290, and I'm going to divide that by 1, 2, 3, 4, 5, 6, 7 pieces. And when I do divide that by my 7 pieces, my sample size, I get 7041. 7041.429. I'll go ahead and write those down. So wow, and now I have my X bar. I also need to know what am I going to use for T. I know my degrees of freedom are 6, and I know I'm going to the 99% confidence interval. So I'm going to go to my table. And on my table, I have 7 data values. My sample size is 7. My degrees of freedom is 1 less than that, so I'm going to go on over here to 6. And when I go over here to 6, I'm going to help my eyes to behave. And try it again. And looking at 6, if I want the 99%, I haven't gone over far enough, so go over a little bit further, and I'm getting 3, so 6 all the way over to the 99% confidence interval. I have 3.707. So my t sub alpha over 2, on my chart it says 3.707. We'll go ahead and peek a little, and we got 7041.429. They stopped it at the 10th, so yay, we have our x bar. We got 3.707 for our t sub alpha over 2, and so did they. The world is a happy place. But we also need our standard deviation for the sample, and this is what I wanted to practice. So I've got me a table started, and you're probably thinking, I don't remember this. It's been a while. So grab your chart, and let's look over here at Chapter 3. And when we look at Chapter 3, standard deviation for a sample, there was a shortcut formula, and that's the one I want to use. My standard deviation for my sample is going to be the square root of, and so I've already rewritten it down here at the bottom. I rewrote it from here that it's my sample size times the sum of all of the x squares minus, I'm going to sum up all of the x's, and then I'm going to take that number and square it. And I'm going to divide it by, well, my n was 7, or is 7, and my n minus 1 is 6, so this will be 7 times 6, or 42. We'll get to that. But first I need a chart, and I'm going to start with this piece here. I want to sum all of my x values. And so on my chart, I have a column for my x values, and I put each one. My 5460, my 5900, my 6090, etc. I put all 7 of those there, and when I add them up, I got 49290, which is exactly what I got a while ago when we were calculating the mean of the sample. So now, this is a harder piece, but I'm going to lazy out on it. I've already done it once. We've already looked at this. But what I want to do is just to show you how to use your calculator and not waste a lot of time writing information down as long as we can do it accurately. And so on the calculator, there is a key. And if you don't know where yours is yet, if I wanted to do like 3 squared, I can punch 3, and where is it on here? Right there, square. And 3 squared, when I hit equals, will tell me it's 9. So I found my squared button. So you got to play around with your calculator, and here we go. So I'm going to do 5460, and I'm going to tell it I want that squared, but I don't care what it is. I'm not going to write it down in that blank. I'm just going to say add to this next one, 5900 squared. Again, I really don't care what it is. The calculator is going to do that for me. Plus 6090 squared plus 6310 squared plus, and I'm going to double check it every time. I'm going to look down and make sure I wrote down 7160 squared plus 8440 squared plus 9930 squared. And when I hit equals, I get a very large number, and it's this number you can barely see down here, 362,629,900. And so that is my x squared sum. So that's the sum of my x squares. And so I'm going to just start typing into my formula. If I can do it very carefully, I'm going to type in the sum, I'm going to type in n, 7, times this sum of my x squares. I'm going to hit equals, minus what's sum of the x? It's this number here. And I'm going to pop the same square button again. I'm going to go ahead and hit equals and then divide by. I know this is 7, I know this is 6, so I'm just going to divide by 42 and hit equals. And then I'm going to do square root. I've got to finagle it a little bit on this one until it's square root my answer. But when I square root it, I'm not going to write down all of this mess. I don't have time for that. You don't have time for that. So here we go. Since that's already in my calculator, I'm going to start there and not retype it. That is my sum of my x squares. So I'm going to tell it times, that was my answer, times my sample size, which is 7. And I like to hit equals. Now I'm going to hit minus. So you need to practice this with me, and then cut the video off, and then practice it by yourself. Minus my sum of my x's, my 49,290. But it says it wants the sum of my x's squared. So I'm going to square that, and I'm going to hit equals because I don't trust my calculator. I'm going to divide by, for this division line, this vinculum, 7 times 6, which is 42, and I'm going to hit equals. And all of this mess is what's sitting under my square root, so I need to do square root of this answer. So I have to get kind of creative. I've got to do second this x squared, and it's like, oh, you want to do square root of what? My answer is hiding above this key, so I have to do second and then this key, and it says I want to square root that last answer. And when I hit equals, I get that the standard deviation of my sample is about-ish 1610.27356. And when I look up here where it goes in the formula, this 1610 dot, that would be a 3, is what they have used. I wanted to walk through all of these pieces because it's been a long time since you've seen that. This is a great place to bring it back in. All of this is happening, and I would lazy out and pop this in my calculator and write it down, because I will take my mean that I found over here, subtract this value, and I'm going to write it down. And then I'm going to take the same mean, but I have to do this times my t sub alpha over 2, and I need to write all of that value down. And then same thing back here, write all of that value down. Then I'm going to subtract it on one side, add it on the other, and I get my range, is what we ultimately were looking for this 99% confidence interval, and then they get us a finishing statement. One can be 99% confident that the population mean number of home fires started by candles each year is between 4,700-ish and 9,200-ish, based on a sample of home fires occurring over a period of 7 years.